Let's now move on to authorization solutions part 2. Now here we're going to talk about directory services, and directory services are the principal means of providing privilege management and authorization on an enterprise network, as well as storing information about the users, the security groups, and services as well. Now, there is a particular protocol used here, and that is the Lightweight Directory Access Protocol, the LDAP. It's a protocol used widely to query and update X.500 format directories. Now, X.500 are the most popular format for directories. Now, here in such directories, you will find attributes like a distinguished name, the DN. This is the unique identifier for any given resource within such an X.500 like directory, and it is made up of attribute equal value pairs separated by commas. Now here's an example from Microsoft. You can see the names right there. You got the CN equals administrator, CN equals Bobby. CN here stands for the common name. We'll talk about that a bit later. But then you have the class, and then you have the distinguished name. You can see the attribute value pairs right there. CN equals administrator, CN equals users, DC equals classroom, and so on. So in your directory services, the types of attributes and what information they contain, and also the way the object types are defined through those attributes, is described by the directory schema. Now, just like we saw here, the CN, DC, and so on, what exactly are these? The CN is the common name. You can have the OU, which is the organizational unit. The C will be country. DC will be the domain component. So as an example, let's imagine we wanted to add the web server operated by a company called Widget from the UK in the directory. It will be something like this. Okay, we'll have CN equals widget web, just as an example, right? And then OU, in this case right now, could be marketing, it could be HR, it could be advertising. The O will be equal to widget, which is of course the organization. And then C, which represents country, will be equal to the UK. The domain component will be widget. And then the DC, another DC could be the FOO. Now, let's talk about the federation and attestation. Now, under federation, this is the notion that a network needs to be accessible to more than just a well-defined group of employees. So in a business, for example, a company might want to make parts of its network open to third-party suppliers, partners, contractors, and maybe even customers. So federation here would mean that the company trusts accounts created and managed by a different network. As an example, this is something that happens every single day. Let's say maybe even you have both accounts on Google and Twitter, you have the applications. So if both of these companies were to establish a federated network for the purpose of authentication and authorization, then the user might be able to log on to Twitter using their Google credentials. You've seen this happen way too many times before. When you're trying to sign up for an account on the website, they might say, hey, you can use your Facebook account to create an account. You can use your LinkedIn account, and so on. That's what we call federation. Now, we also have the identity providers and attestation. Now, in these models, the network will perform federated identity management. So a user from one network is able to provide attestation that proves their identity. Here is an example of what you might see. So in step 1, the user or the principal will attempt to access the service provider, the SP, or the relying party, RP. So the service provider will then redirect the principal to the identity provider, the IDP, in order for them to authenticate. So here right now, the principal will authenticate with the identity provider and will obtain an attestation of identity in the form of some sort of like a token or a document signed by that IDP. And then in stage 3, the principal will present the attestation to the service provider. The service provider can then validate that the IDP has signed the attestation because of its trust relationship with the IDP. And then in stage 4 right there, you can see that the service provider can now connect the authenticated principal to its accounts database. It may even be able to query attributes of the user account profile held by the IDP if the principal has authorized this type of access. Let's move on to cloud versus on-premises requirements. Now, when a company needs to make use of cloud services or share resources with business partner networks, authorization and authentication design will come with more constraints and additional requirements. It's going to become even more complex. For example, A federated network or cloud will need specific protocols and technologies to implement user identity assertions and transmit attestations between the principal, reliant party, and identity provider. Now, how do we solve this? We can make use of a very powerful language known as the Security Assertions Markup Language, the SAML. Now, the SAML authorizations are written in Extensible Markup Language, XML, and communications are established using the HTTP, HTTPS, and the Simple Object Access Protocol, SOAP. However, many public clouds will use Application Programming Interfaces APIs based on representational state transfer, REST, rather than SOAP. Now, authentication and authorization for a RESTful API is often implemented using something known as the Open Authorization Protocol. The Open Authorization Protocol is designed to facilitate sharing of information with a user profile between sites. Now, the user account is hosted by one or more resource servers. A single authorization server can manage multiple resource servers. Now, the OIDC is explicitly designed to authorize claims and not to authenticate users. The access token once granted has no authenticating information. OIDC, by the way, is the OpenID Connect. So thank you so much for watching the video. I will see you in the next class.